Okay, hey everyone. I'll be doing the week 2 math AMS of grade 10. Now the solutions is already on the drive. It's here. It's on the YouTube channel link. So you just go here, press more, press solutions drive link. Just goes this. You go math, and then you'll find it here. Just bring it here. I'll download the file, and I don't need to download it. I'll get started right now. Okay. So, which of the following relations is not a function? Select all that apply. Now, a relation is defined as a function when the relation only generates one result, like each domain, each x value, it only gives out one y value. So, we'll try that here. I'll explain it later in another question. I think it's question 10. Yeah, I'll explain it in question 10. So which of the following relations is not a function? Select all display p given by y equals p of x equals y and y equals x minus 4, absolute value of course. So this is a function because x minus 4 an absolute value can only be one value, can only give out one value. Even if without the absolute values it will still give out one value. Now q given by y equals q of x and y in absolute values is equal to x minus 4. Now here it gives y could have two values. Like for example, if you were to have y absolute value of so this gives you 5, for example, or negative 5, then the y value would be 5. Sorry, the y value would be 5. Now the y here could be like if you remove the absolute value, this would be a function, but it's not, because in absolute values that means you don't know if the original value was negative or positive. So like the original value of this could have been negative 5, but since it's an absolute value, we changed it to 5. So there are two answers. There could be two values for this relation, making it not a function. Now, r given by y equals r of x and y to the power of 4 is the absolute value of x minus 4. This is a relation, not a function. Well, each relations are functions, but the difference is that some give out two values, some don't. This isn't a function because this is an even exponent, and you know even exponents, they can have a positive answer or a negative answer. So like negative 2 to the power of 4 would give you 16. Or sorry, negative 2 to the power of 4 would give you negative 16. No, it would give you 16. I'm not thinking properly, I'm sorry. But at the same time, 2 to the power of 4 would also give you 16. So there could be two values for y, which makes this a relation, not a function. S given by y equals s of x and y equals x minus 4 squared. Okay, now here x minus 4 squared will have only generates one y answer. So even if you're to have negative 6 minus 4, which would be negative 10 squared, negative 10 squared would be 100. Now, this would only give one y value. Like each x value will only generate you one y value. Basically, the general rule is if there is something on the y side of the equation that would make it have two values, like an absolute value or an even exponent, then it would generate two y values. Two y values. Sorry. So here it doesn't have anything to do with the exponents or anything to do with the absolute values on the y side, making this a function. Same with this, as you can see, y is alone. Like even if they would have 5y, but it's not something that would give you two answers or 3y or anything. As long as you have an odd exponent or a coefficient or anything that doesn't change the answer to give it two values, it's not a relation. It's a function. Well, all functions are relations. So, just to clarify. Okay. This is the opposite of the other question. Which of the following relations is a function? Select all that apply. S given by y equals s of x and y to the power of 4 equals x minus 1. See what I mean here? Y to the power of 4. So this is wrong because this makes the y possibly have two values. Same with this because there's an absolute value of y, so it could be a positive answer or a negative answer. But to change it to positive, so we would never know. Now, u given by y equals u of x and y equals x minus 1 in absolute value. As you can see, y is isolated, y is in 1. There's nothing that could make it have two values, so this is fine. X minus 1, this is fine. Okay. y equals x minus 1 to the power of 5. Y is alone, isolated, same rule. And same thing with this one. Now, if you were to have y cubed, it would be fine. Like it's not gonna give you two answers, but it's okay. But it's just the even you have to worry about. Okay, so the figure below displays three circles. Two of the circles each has radius of 2, while the radius of the third is 4. Now, how do arcs become congruent? Arcs are congruent only when the radii or the measures are equal. Sorry, the measures of the lines that are between them are equal, and the angles are congruent. So here, I don't have anything to draw with, so this is going to be a bit of a problem. Let me see if I have it on this. No, I don't. Okay. Uh, so here you're gonna have CB congruent to AB because they're in the same circle and they're radii, so the measures are equal. Measures of the radii are congruent, and the angles are congruent. As you can see, they're both 50. So this would be CB congruent to AB. Now, CB would also be congruent to QR, and CB would be congruent to RP. Same with AB. Because as you can see, the measure is 2, and the measure here would be 2 as well, and the 50 is here, the 50 degrees here, 50 degrees here, so they're congruent. And these two are congruent, so these two are congruent as well. And now QR is also congruent to RP. Now, this circle isn't congruent to any of these two circles. This circle, the arcs in this circle are only congruent to the other arc. As you can see, this is 50, this measure is 4. Here, this measure would be 4 as well. So this would be, LK is congruent to LM, and nothing else for this circle. So let's see, minor arc AB is congruent to minor arc PR. AB, PR. Yes, as you can see, the measure is 2 here, the measure is 2 here, the measure of the angle is 50 here, the measure of the angle is 50 here. So this is correct. Minor arc LM is congruent to minor arc LK. I just explained this. It's the big circle. It's not congruent to any of the other things. It's congruent to the other arc because they have the same measure and the same radii. Okay. Now, which of the following is true about the measure of a minor arc? If the central angle is obtuse, its corresponding arc is a minor arc. If that's correct, but now you might ask me, why is the second option also correct? Because it says acute here and its corresponding arc is a minor arc. Basically, an obtuse angle, a lot of people mix this up, but an obtuse angle is an angle that's greater than 90, but is less than 180. This is the definition of a minor arc. If the arc's angle is less than 180, it even defined it here. It's a minor arc, it's not a major arc. Greater than 180 makes it a major arc. So, if it's obtuse, it's a minor arc. If it's acute, it's a minor arc. Only and only if the angle is greater than 180, that would make the arc a major arc. Oh, the voice crack. Okay. In degrees, the measure of a minor arc is less than 180. I just explained this. It is true about the measure of a minor arc. If the central angle is straight, its corresponding arc is a major arc. It's complicated because it's technically a semicircle, but like it's not right. Basically, that's the point. It's not right. Okay, in degrees, the measure of a minor arc is between 180 and 360. I just defined this as the major arc. This is wrong. This is the major arc. This is not the minor arc. In degrees, the measure of a minor arc is equal to 90. This is wrong. While 90 degrees, yes, it is a minor arc, but it's not exclusively 90 degrees. It's between 1 degree and 180. Okay, so question 5. Which of the following is the central angle of the circle? Now here, I said, let me just zoom in. The central angle is equal to any angle with the center of a circle. So like POK or POL or LOM or NOM. So let's see what we have here. Basically, how you define an angle. You define an angle by the angle you mean, like the actual angle in the center and where those two lines meet. If I had open board, I would actually, I'm just going to get it set up right now. While I'm opening it. So central angle is basically any angle that passes through the center. So POL, yes. MON, yes. And LOM, yes. Because as you can see, they all pass through O. Okay. Now, that's question 5 done. Which of the following points belong to minor arc Kn? Select the 4 options. Okay. Minor arc Kn is this arc, Kn. Now they're talking about the minor arc, so not the major area. Why Why is it important to define an arc to be major or minor? Because let me just figure this out one second. Okay, so yeah. Okay. So while this is installing, let's see. Define minor arc Kn. Select the four options K, R, L, N. Okay. Let's see. What minor arc Kn is this arc right here, this area. So you just select the points that are on this arc, which are points K, points R, point L, and point N. Okay, that's correct. Now open board should open if it decides to, of course. Launch open board. Yep. Okay. Now I'll go to the desktop. Okay, so this is the arc they're talking about. Uh, Kn. So it's this area. So you just use the points K, point R, point L, and point N. I'll just move on to the next question after I erase this. And question 7. Okay. The diagram below shows a circle with a center C. Which of the following points belong to a major arc GD? GD. So it would be this. This is major arc GD. Now, why is it important to define if an arc is major or minor? Because if you said minor arc GD, you would mean this area. Yeah, you wouldn't mean this. So, let's see what they want. The points. So it would be points D, F, B, and G. Because they're all lie on the arc here. Okay. So now, I'll move on to question 8. G, B, F, T. Yep, like what's that? This is the same one I did before, so I'm just gonna gloss over it. KL is congruent to to LM, but they don't want that. They want PQ only. I should have read the question. Minor arc PQ, so obviously it's congruent to QR, it's congruent to XY, and congruent to XC. Okay. Moving on to question, same story. DE, congruent to DE, EF, AB, and BC. Okay, so now question 10. Okay, this question is a big question, I would say, because it's kind of difficult. It's long, but it's easy. Now, the way I solved it is a way I would do it in a written. Don't do this on a normal exam because it's not that good for a written for a computer exam because it's going to take way too long to write. So relation T is defined by the rule y equals negative 1 plus 2 plus or minus 2 root x. Now yeah, they gave you the domain D to be defined as the values 0 and 1 and 4. You define range R, so I wrote range R defined as R, corresponding elements of domain D and of relation T, because the domain, the range corresponds to the domain in a relation, which is what I just essentially wrote here, just in different like different structure. To find the number of values and the number of to find the number of values and the values themselves of range R, you substitute the values of the domain as x values and t. So you basically use the domain here. You use the values of this domain as x values. So each domain, so like 0 instead of x, 1 instead of x, and 4 instead of x. So we start with the 0, obviously. Now I did note this because this note's important. You will need it for later questions and for this question itself. The domain is the x value and the range is the y value. On a coordinates on the graph would be that the domain value is the x and the y value would be the corresponding range value of that domain. So if it's a bit confusing, you'll understand when I actually solve the question. So you find the values of the range R. Now you try 0 first, because that's the first value in our domain. Y equals negative 1 plus or minus 2 root 0. Y equals minus 1 plus or minus 0 plus or minus 0. It's just like that's useless, so it's pretty much you ignore it. So like an x there. Y equals negative 1. Okay. Now you move on to the other value of R, which would be, what was it, defined as 1. Yeah, okay. So y equals negative 1 plus or minus 2 root 1. 2 root 1 is essentially just 2 because the root of 1 and the square of 1 is 1. So you just cross this out. negative 1 plus or minus 2. So you split this up into negative 1 plus 2 and negative 1 minus 2. Um, so what you'd get, negative 1 plus 2 would give you 1, and the y value, and the other one would give you negative 3. Okay, so negative 1 plus or minus 2 root 4. Uh, Negative 1 plus or minus 2 multiplied by 2 because root 4 is 2. Negative 1 plus or minus 4. Negative 1 plus 4 is 3. And negative 1 minus 4 is negative 5. Those are our two y values. Okay. So now you have your range are defined as the values negative 1 and negative 3, 3 and negative 5. Don't worry about ordering them. In a written exam, it's preferred to order them, but don't order them in a computer exam. Now you have 5 values to answer our first question. Now they ask the relation T is not, or is or may be a function. These are your options. Now it's not a function because, as you can see here, we got two y values. We got more than one for these. So that makes it not a function, it makes it just a general relation. Okay, part B. Select the points that belong to the given relation. Now, you use this note for part B. You find the values of the domain, so 0. You don't even need to look at the domain, you just look at the values you substituted for x, which are essentially the domain values. As you can see, 0 and our y was negative 1, so I write it down, 0, negative 1. 1 for our x, and we got 1 and negative 3, so you write both of these down, 1 and 1 and 1 and negative 3. Now for the 4, you do the same, and these are your points. Now you plot them on the graph. As you can see, 0, negative 1, 1 and 1, 1 and negative 3, 4 and 3, and 4 and negative 5, which were our points. Okay, so now question 11. Okay, true or false, all of this 1, 3, 2, 2, and 3, 1 is an example of a relation that pairs elements from set A to elements from set B, which are 1, 2, 3, and set A is 1 and 2. Now, why is this false? It's false because if you want a relation to pair elements from both sets, all of these numbers, like this set, for example, this number must be common in both of these sets. As you can see, 1 is common in set A and set B, 2 is common in set A and set B, but 3 is common in set B, but not in set A. So this is wrong. It doesn't pair them together. It's not a correct relation to pair them. Now, if you were to remove this 3 and, for example, were to put 2, and if you were to put 2 here as well, or like 1, this would be a correct relation. It would pair set A and set B together, but it doesn't, so it's wrong. Question 12, right, consider the relation R, which this is one of the questions where you use the note I gave you on in terms of the coordinates. The domain is the x value, as I said, and as you can see, this is ordered by increasing in increasing order. So the first one is 12, which is the smallest. You can just check the other x values. You'll find that 12 is the smallest, so it's 12. This is the y value. This is the range. So this one isn't ordered. It's ordered by the domain. The range values are not ordered. So it's 12, 13, 14, 17, 19, 11, and 10. 10 is the smallest value, so I write 10 here. Okay. Consider the relation R containing the following elements: 1, 2, 12, 23, 12a, blah, 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 where A, B, and C are constants to be determined. What must be the value of B for R to be a function? Now, how do you know if, again, a function only gives one y value for each x value? Y1 for x1. So here they're trying to trick us. They're trying to make it complicated, but it's much simpler. As you can see, if for this to be a function, this must be repeated. There can't be a different value for the y. There can't be a different range. So 23 is for A, B is 16, and C is 20. Okay. Now, here, this question test is about the vertical line test. Now, the vertical line test is a test to determine if the relation is a function or not. What you do, you draw a vertical line. Let me just snip this out. Okay, to bring current page. Now, what you do, you draw a straight line. Um, you draw a straight line on an actual like grid. As you can see, I'm not exactly on the grid, so it's not going to be accurate. But you draw a straight line. What you do now, if there's 2 points or more than 1 point on this line, then it's not a function. It's a relation. It's just a general relation. It's not a function. So what this means is that like right now there's 2 points. So this is not a function. This is just a general relation. Now they asked you which point, if removed, makes the relation a function. If more than 1 point exists, enter any of them. P or U are correct answers, because if you remove U, it would make P correct, and that's what would make it a function. If you were to put P, U would be the, if you were to remove P, U would be the correct only point, and it would still be a function. Okay, so now question 16. The function P is given by P of T. Basically what you do here, you substitute P negative 2 and negative 2 instead of P. So it would be 5 minus 3 times negative 2. Which would be, which you'd multiply 3 by negative 2, which would be negative 6. 5 minus negative 6 would make it a positive 6, which would make it 11. Okay, so same thing here, except now they added 3t plus 1. 3t plus 1, so you expand this into a plus b squared, is the remarkable identity we took last year. You expand, you'd get this 90 squared plus 60 plus 1. You distribute the 2 across it, 11 plus 18t plus 12t plus 2. Combine like terms, and here there's the only two like terms are 11 and 2, so it would be 18t squared plus 12t plus 13, because 11 plus 2. Now they only want one blank, which is the 13, so 13 would be our answer. Okay, same thing here, except they want you to find the largest range. Now this is addition, so obviously it's going to be the largest number. So you just substitute the largest number in the domain for here, and you'd get the largest value. So it would be P of 20 equals 10 to 10 plus 2 times 20. 2 times 20 is 40. 10 plus 40 is 50. P of 20 is 50. Okay, now the function h is given by h of x minus 48 root of 48 minus 4x. The function of the domain of h is x. Okay, what this means, which value, how do you know that this, like which numbers are only accepted in this function for this function to be defined? So what you do, obviously in a square root you can't have any negative values, so you set it uh, greater than or equal to 0, because if you were to put it 0 it would still be defined, it's still correct. So 48 minus 4x is greater than or equal to 0. Now, you take the 48 to the other side. Negative 4x is greater than or equal to negative 48. Divide by negative 4 on both sides. When you divide by a negative number, you switch the inequality. The sides change basically. So x is less than or equal to 12, which, as you can see, is the correct answer. Now, the function h of x equals x plus 11 over 2x minus 66. What number is not in the domain of h? What this means is basically what number would have to make this function invalid, undefined. So what you say, in order for h of x to be defined, 2x minus 66 cannot be 0, because what you define the domain of function h. And it's an example. Why can this number, the denominator, not be 0? Because remember, if you cannot divide by 0, you can divide 0 by something, but not, you can't divide by 0. If you were to divide this, if this were to equal 0, then the function would be undefined, so it would not be in its, so you need to find the number that would make this function undefined, which is the only number, theoretically the only number outside of this domain. Now, 2x minus 66 cannot be 0. Take 66 to the other side. X cannot be 33, which is our answer. The same thing. X squared minus 5x plus 4 cannot be 0, so you can be defined. Now, x minus 5. So basically, now x squared minus 5x plus 4 cannot be 0. You factor this out into x minus 4, x minus 1. Okay. So sorry, my mic cut for a second, I don't know why. You factor this out basically and set it not equal to 0. Now, in a quadratic, if you forgot, these both terms uh, equal 0. But here in a quadratic, the whole thing equals 0 basically. This, like for example, a squared minus b squared plus c. This is just a general quadratic equals 0. So its factors, let's just say it's a plus c and a minus c. Obviously, like we don't know, but say it was. These equal 0. Now, what you want to do here, so you set a plus c equal to 0 and a minus c equal to 0. Now here it's the opposite. They want it to not equal 0. So what you do, you write not equal to 0 and not equal to 0. So our values, x cannot be 4 because x minus 4 cannot be 0 and x minus 1 cannot be 0. So you take x minus 4 to the other side, x cannot be 4, and you take minus 1 to the other side, x cannot be 1. Now they said if more than one number exists, enter any of them, so you can enter either 1 or 4. Now, this is about arcs. This is why they added the third letter to define whether it's a major arc or a minor arc. Now, PSR is all of this. This is obviously greater than 180, so this is a major arc. Now, PQR. See the difference in letter? Like if you were to remove the Q and R, you would not know which arc to they're talking about. You could PR could be this arc, or PR could be this arc, but they added the third letter to define which arc it is. No, that was an accident. My bad. PQR is this, which angle is clearly less than 180, so this belongs to the minor arc. This is the minor arc. Now, PQS is this whole thing, which is obviously greater than 180. Like you can see, now I can't draw it because it's hard to draw because of my terrible drawing skills with the open board. But it's greater than 1. Okay, I'm sorry. Apparently my mic cut out. I just realized. Let me just re-explain the whole thing. So basically, what I said, you only the point they if they ask you the which point, how many points belong to the circle, you only define it as the only points you take are the points on the line, because a semicircle you don't know which side they're talking about. It could be this point, this side, sorry, or it could be this side. So it's you so in order to avoid any confusion, you only take the points on the line itself that define the semicircle. So the points are KCSN, which are 4 points. So you write your answer as 4. Now, question 24. If the degree of measure arc minor arc LM is 70, the degree of minor arc MN is 110. Now, 110 is, so this is 180, right? 70. 70 is here. And so this would be 180 minus 70 to find the measure of this. So it's 110, because 180 minus 70 is 110. Okay, I'm sorry, my mic keeps cutting out for some reason. Okay, I'm sorry. Yeah, my mic just keeps cutting out for some reason. I don't know why. Now the measure of major arc AB. AB is all of this. AB is this. This is what they're talking about. Now, uh, the AB, it'd be Obviously, this would be 360 minus 115 because the degree of a the degree of an entire circle is 360. Sorry, so you'd be 360 minus 115 to find all of this, right? Because this is the other part. So 85. So if you were to ask, for example, because the 85 is only for AD. Now, if you want AB, it includes the 85. So out of 360, it's 85 plus X. So AD plus AB. Or so it would be 360 minus 150. I'm sorry, if it's not clear enough, I'll explain it in the comments. Just tell me if it's not clear enough. 360 minus 115 because it's basically your because it's kind of hard to determine this without any other given. They're not giving us much given. So don't get confused and say don't draw like an imaginary line and say 180 is this and like that because it doesn't make sense to do that because this is only for AD. They want the entire arc which includes AD. AB has AD in it, as you can see. What's left is this part, which is 115 degrees. So it would be 360 minus 115, which is 245. Okay. Now, this question, by the way, it's wrong. Technically speaking, it's wrong because the midpoint was never defined to be the midpoint. Like here, point M, it's a midpoint, but it was never defined to be one. So what you do, uh, basically, where is it? Let me look for the question. It's question 26. Here it is. Okay, so you go start from G. Now you know each one is 30 because it's 12 congruent angles and each angle is 30. So GFM. GF is 30 and then FM is 15. So 30 plus 15 would be 45. 45. That's our first part. Now 45 plus 15. Why I said 15? Because you could just group 15 plus 30 plus 30 plus 30 plus 30 into 105. Like group them all together. But it would be like 105 is an awkward number to add up. So instead, just take it. So this would be 30 and 30 plus 15, which would be 45, plus 15 to get to E and start from E counting 30 mentally. So 45 plus 15 plus 15 or sorry 30 plus 15 plus 15 so 30 45 plus 15 then plus 30 plus 30 plus 30 now you could do plus 30 plus 30 plus 30 mentally which would be 90 so it would be 45 plus plus 15 plus 90 so now moving on to the next question which should be the similar to the other one okay now this one encompasses. Okay, so UCW. Now UCW is the points here. You would don't. I made the mistake. Don't define it like this. Also, okay. The measure of minor arc. And now there's a rule. If the arc encompasses basically goes around this arc goes around the two other arcs, you set these two equal to whatever the measure of this is. So x minus 100 plus 2x minus 220 equal to x. Now, I'm sorry if I'm rushing through these last questions because I have to go in a bit. So let me just clarify here. X minus 100 plus 2x minus 20 equals x. 3x minus 320 because you combined like terms is also equal to x. Take x to the other side and take 320 to the other side. 2x equals to 320. X equals to 160, which is our answer. Okay, now our application of okay. The diagram below shows a circle with center C. Same thing as the other one, but instead here they said this arc is congruent to this arc. So it's basically x minus 15 plus x minus 15 equals to 150. Now don't say x minus 15 plus x minus 15 equals to 150 because that's longer, honestly, in my opinion. So just say 2 times x minus 15 equals to 150. It takes shorter to write basically. because in math, you need time. So 2 times x minus 15, you distribute the 2, 2x minus 30 equals 150. You simplify, 2x equals 180, x equals 90. No, I think, yeah, okay, no, never mind, that's the last question. So the diagram below, this is the same one as the other one, but it's easier. So minor arc KC. KC, minor arc, so it's this part, right here, this part. So 30 plus 30 plus 30 plus 30. Now 30, 60, 90, 120, and 120 is our answer. Okay. My throat's locking up, sorry. The measure of major arc EB. The EB would be this right here. This would be major arc EB, which is why, again, it's important to define an arc if it's major or minor. Okay, so EB, 30 here, so 30, 60, 90, 120, 150, 180, 210, 240, 270. So 270 degrees and 270 is our answer. Okay, so this is the end of the quiz. That's all of this week's math done. Now, obviously, do the book, or no one, I know no one does the book, but like, try doing the book because it has some exercises that are important. Good luck.